It is easy to separate this data set into two by a linear line. This type of data is called linearly separable data. In some cases, the data points may not be separable by a linear boundary. For example, if you have two classes of data points that are intertwined or clustered in complex patterns like that, a linear decision boundary may not effectively separate them. In this case, we have a linearly inseparable data. To overcome this problem, we use mapping to a higher dimension technique. We can transform our linearly inseparable data from two-dimension to a three-dimension by adding a z-axis. This is done by using mathematical functions that map points from two-dimensional space to the coordinates in three-dimensional space. In this three-dimensional space, our data points are now linearly separable. The support vector machine algorithm finds the optimal hyperplane that separates the data points of different classes with the maximum margin. Here, as you can see, a hyperplane separates data into two categories. And when we reduce the dimension, we will have our data set separated into two categories. Here, you might say, well, I can easily separate the points from each other by looking. What is the point of going through all this trouble? Yes, our eyes can separate the data into two categories easily. However, a machine cannot do it by simply looking at data, because there is no visualization for a machine. Machine doesn't see what we see. Machine only deals with data points. Higher dimension mapping is one of these techniques that enables a machine to separate the data. One downside of this method is that it is very computationally inefficient. It takes lots of memory and processing power to be able to map between dimensions. To solve this problem, we use the kernel trick. Let's see what kernel trick is about. The kernel trick is a machine learning technique that transforms linearly inseparable data into a higher dimension where it can be linearly separated. This is done by using kernels, which are functions that transform data. Kernel trick enables us separating data without having to compute the coordinates of the data points in the higher dimensional space. The kernel trick offers a more efficient and less expensive way to transform data into higher dimensions where it may be linearly separated. There are four functions used as kernel. These are linear kernel, polynomial kernel, radial basis function kernel, and sigmoid kernel. Take our AI in a Weekend course now if you want to learn more. Click on the link in bio.